Page 418, lesson 7.1 is on zero and negative exponents. We're going to start talking about it here. Some of the stuff as we go through this, we'll be getting more explanations on it further as we go into the chapter. So if it doesn't make sense all the way right now, hopefully it'll get a little bit more cleared up as we go through the chapter. So in the top of the page, they want us to look at these tables, this table, and kind of make guesses on what we think is going to happen here. So some of this we should be able to fill out without too much problems. For example, 2 to the 4th power means 2 times 2 times 2 times 2. And if you multiply that out, it would be 16. 2 to the 3rd power is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the 1st power is really just the same as 2. And then we kind of get into uncharted territory. What we can do is look at what's happening here when we reduce our exponent by 1. When our exponent, it's 1 smaller, what's happening in this case is we are dividing by 2. Okay, kind of makes sense. Hopefully we have 1 less 2 that we're multiplying by, so basically we take half of what we had, or we divide by 2. We get rid of a factor of 2 each time. What's going to happen, notice our exponents keep going down by 1, so down below here we've got a 2 to the 0, 2 to the negative 1, 2 to the negative 2. So the pattern actually is going to continue, and we'll talk more later in the chapter about why that's the case and how that exactly works. But 2 to the 0 power, then, if you continue the pattern dividing by 2, 2 divided by 2 would be equal to 1. So 2 to the 0 power is equal to 1. If we divide by 2 again, take 1 and divide it by 2, that's the same as 1/2. And then if we divide that by 2, would be 1/4. The 1/4 I'm just going to mention is the same as 1 over 2 to the 2nd power. 1/2 is the same as 1 over 2 to the 1st power. Okay, so a couple things we'll talk about here in a minute a little bit more. If you have something to the 0 power, it's going to be equal to 1. If you have a negative exponent, we're going to make it positive by putting it in the opposite part of the fraction. In this case, it's kind of like it's in the numerator to start out with. We bring it to the denominator, makes it a positive exponent. So the take note box here has basically that information, what we just talked about. We can't have 0 to the 0 power, but for anything else, for every non-zero number, if you take it to the 0 power, it's equal to 1. So for example, 4 to the 0 power equals 1, negative 3 to the 0 power equals 1, 5.14 to the 0 power equals 1. Okay, so you could like try to impress your parents or something and tell them that you know what 1 million to the 0 power is without using a calculator, and you could tell them it would be 1. The next thing it talks about negative exponents, and basically for that, kind of like we talked about, is if you have a negative exponent, and this is really, you could put it over 1 if you wanted to. It's kind of like it's in the numerator. To make it be a positive exponent, we bring it to the denominator. So they give you some examples. 7 to the negative 3rd power is equal to 1 over 7 to the 3rd power. Negative 5 to the negative 2nd power is equal to 1 over negative 5 to the 2nd power. If we had a little different, if we had 3 over a to the negative 2nd power, that would be the same as 3a squared. This time we had a negative exponent, but it was in the denominator. So it's kind of like we bring it to the numerator to make it positive. And like I said, as we go through the chapter, we'll be going through more of kind of the reasoning of why this works. So kind of I look at it like this. A negative exponent becomes positive by putting it in the opposite part of the fraction. Okay, so if it's in the numerator, or if you don't have a fraction, if it looks like you don't have a fraction, if you put it in the denominator, that'll make it be a positive exponent. If it's in the denominator, like on this example I mentioned, if it's a negative exponent in the denominator, we make it positive by bringing it up to the numerator. Top of the next page just kind of mentions about why we can't have 0 as a base, and then also why we can't, why we can't have a 0 to the 0 power. 0 to the 0 power is undefined. And then it also talks about how we can't have 0 to a negative power. I'll mention that one real quick. Like if you had 0 to the negative third power, that would be 1 over 0 to the third power. 0 times 0 times 0 is 0, so that'd be 1 over 0. And kind of like we talked about when we did slope and stuff, if you have a 1 in the denominator, if you have a 0 in the denominator, that's undefined. So we can't have 0 to the 0 power. Also, we can't have 0 to negative powers. So if you look at problem 1, simplified form, they actually mention right before problem 2. I'm not sure why they don't mention it here, but anyway, we have something, algebraic expressions are in simplest form if we have just positive exponents. So 9 to the negative second power, to make that a positive exponent, that would be like 1 over 9 to the second power. And then 9 to the second power means 9 times 9, which is 81. So this is equal to 1 over 81. Part B, we've got negative 3.6 to the 0 power. It's to the 0 power, so that's going to be equal to 1. So if we look at the got at 1 simplified form of these expressions for part A, to start with, we can write that, since it's a negative exponent, we can write it as 1 over 4 to the third power. 4 to the third power is 4 times 4 times 4. So that would be 1 over 64. Part B, negative 5 to the 0 power is equal to 1. On part C, 3 to the negative second power is the same as 1 over 3 to the second power. 3 to the second, 3 times 3 is 9. So that would be 1/9. Part D, we've got 6 to the negative first power, so that would be 1 over 6 to the first power. We really don't have to put the first power on that. We could just make that 1/6. In part E, would be 1 over negative 4 to the second power. And that would mean negative 4 times negative 4, which is a positive 16. So that would be 1/16. Once again, right above problem 2, it does mention about simplified, simplest form if we have just positive exponents. Problem 2, we just got a little bit more stuff happening here. More variables and coefficients and things. Our focus should only be on the negative exponents. If there's not a negative exponent, we're just going to leave it alone. So this one, we've got b to the negative second power, which would be 1 over b to the second power. And then you could multiply straight across. The other thing, if you want to, is you could just say, I'm going to go straight to the answer, and just know that if this is a negative exponent, I'm going to bring it to the denominator, make it positive, and all the other stuff that didn't have negative exponents is going to stay in the numerator. Part B, this time we have this negative exponent in the denominator. The book kind of steps you through the process so you can see what's happening and kind of understand maybe why this works, what I was mentioning earlier. We can first write this sideways. We can write 1 divided by x to the negative 5th power. We know x to the negative 5th power is the same as 1 over x to the 5th power. And then for dividing, we can do keep, change, reciprocal. And so then basically we've got 1 times x to the 5th power, which would be x to the 5th power. Okay, but like I said earlier, rather than going through all the steps on that every single time, we could just note that we have a negative exponent in the denominator. We take it out of the denominator into the numerator, you could think of, and that makes it a positive exponent. So if you look at the got it 2, they want the simplified form for these. So part A would just be 1 over x to the 9th power. Part B, our negative exponent is in the denominator, so that's going to be the same as n to the 3rd power. On part C, most of this is actually positive. We've got just a 4, we've got just a b. It's just that middle part, the c to the negative 3rd, that we've got to get out of there. So that could go to the denominator as c to the 3rd power. And then the 4 and b can actually just stay where they're at. So just keep them there. And that would be our answer. Part D, we've got a negative exponent in the denominator. Let's bring it to the numerator to make it positive. And then part E, the m squared is fine where it's at. It's already a positive exponent. N to the negative 5th is what we've got to work with here. Since it's a negative exponent, we'll bring it to the denominator to make it positive. At that point, we've pretty much vacated our whole numerator. We can't just have a fraction with a denominator and no numerator. So we do need a numerator here. Just remember, you can always put a 1 in front of anything. Put a 1 as a coefficient if you don't have one there. Multiplied by 1 doesn't change anything. And so 1 over m squared n to the 5th would be our answer for that problem. If we look at the lesson check, we'll go through numbers 1 through 4 here. Do you know how? So number 1, that would be the same as 1 over 2 to the 5th power. Number 2 is to the 0 power. That would be equal to 1. Number 3, most of this is fine where it's at, just the negative exponent we got to deal with. So we'll bring that part to the denominator as t to the 1st power, and that's just the same as t, so you don't have to put the 1st power next to it there. And then on number 4, we have a negative exponent in the denominator, so let's bring that up in the numerator. It would be 4x to the 3rd power. So I'm just going to break this up here, so we're going to stop at that point, and then we'll be learning a little bit more the next time about how to deal with 0 and negative exponents. Have a good day.